All right. Hello, everybody. Next up, we have a story that hits where it counts. It sounds a little bit like a really good LinkedIn advert. Real savings, real results, real open source. Because sometimes open cloud security isn't just about better visibility or fewer breaches. It's about cutting massive costs and gaining more control. And in this session, I'm personally very excited to hear how one team did just that. So please, to tell us all about it, put a massive hands together for Paul Schwarzenberger from Q-Solutions. Paul's a veteran cloud architect who's been working with some of the largest financial and government orgs in the UK. He knows cloud security inside out, and he's not afraid to challenge the default settings. Today, he's going to share how his team replaced a commercial certificate authority with an open source private cloud CA, saving $70,000 a year without cutting corners on trust or security. So please welcome Paul Schwarzenberger to the stage. Paul.
Yeah, hi everybody. Great to have you here, and I've really enjoyed the talk so far. I hope you have too as well. So I'm going to get straight on with it, and I'm going to share my screen. And as we just heard, I will be talking about how we saved $70,000 a year with our open source private cloud CA. So at Q-Solution, we are a specialist company that provides software as a service and PaaS services to the UK government. And we most of our services center around secure communication and messaging between different government bodies, public sector organizations, and collaborating organizations as well. So historically, these secure communications have been enabled by private government networks. However, these are increasingly expensive, difficult and problematic to maintain, and prevent collaboration with organizations that, for whatever reason, are not able to connect to these networks. So there's a strong incentive to move to secure communications by a community of different bodies over the public internet. So we were thinking, obviously, how are we going to go about doing this? And we looked at using mutual transport layer security, or mTLS, in other words, mutual certificate authentication, as an ideal method to secure that trust. So being a cloud-first company, we host our services in different clouds, but mainly AWS, Amazon Web Services. And so we started by looking exactly at AWS for what options there were in this space. And we looked at AWS Private CA. However, the cost of that is $400 per month. And then on top of that, there's a 75 cents per certificate. So that might not sound, well, that does sound quite a lot, but it might not sound so much for a company. However, we deploy all our environments with we deploy our services using continuous integration and continuous deployment pipelines. And we have multiple environments, and we also have multiple different communities which have different trust models. So overall, we needed 7 environments, and we wanted to have a root CA and issuing or intermediate CA pair for each of those environments. So if you do the maths and add in a bit for the sort of numbers of certificates we're expecting, that ends up being around $70,000 per year, which was just too expensive for us on an ongoing basis. So we decided to develop our own solution. And our strategy is, wherever possible, to use serverless. So we did exactly that. And we adopted a serverless approach for all the reasons that people normally use serverless, which are, that it's low cost and event-driven, and it's with the shared responsibility model, there's much less to worry about. We don't have to patch any servers or update very much at all apart from the code. So we use Lambda functions as the basis for this. They're written in Python using the well-respected Python cryptography module. We store the private keys of the certificate authorities themselves in Key Management Service, KMS, and also generate the keys there too. We orchestrate all of the Lambda functions with a step function. And we have different Lambda functions for different purposes. So we have one to create the root certificate authority if it doesn't already exist. One to publish a certificate revocation list for the root CA. Similarly for the issuing or intermediate CA. And then we issue any end device or end user certificates that need issuing. Yeah, so that's what we did there. We use S3 to store various files, including certificate revocation list files, and we publish details of certificates to DynamoDB, and we send notifications to SNS, Simple Notification Service, where they can be picked up by other workflow or automation type tasks. And we optionally can publish the certificate revocation list and CA certificates themselves to public endpoints through CloudFront. So that's the approach, and the cost of that environment is typically around $5 per month, which is massively less than the AWS Private CA cost. Most of that cost is actually the KMS keys that we use, and the step function only runs once per day by default, so Lambda costs are virtually zero. We achieved our financial aims there very, very nicely. What are the features of the Cloud Certificate Authority? Well, as I mentioned, we store the private keys within AWS KMS. The integrity and trust of a certificate authority is completely dependent on the private keys and the security and integrity of those private keys. So they're generated in AWS, they're stored there, and they are not exportable. KMS is certified to FIPS 142 Level 3. So FIPS is the Federal Information Processing Standard, which is the de facto standard for cryptographic hardware. We have options for elliptic curve or RSA algorithms, both for the certificate authorities and also for the end user or device certificates. We publish certificate revocation lists once per day and can be on demand as well. And optionally make the CRL distribution point and authority information access points, which is basically CA certificates, can be all made public. Because our certificate authority is entirely deployed within Amazon Web Services, access control and permissions is all via AWS IAM, Identity and Access Management. So provided you do it properly, that can be highly granular and very much a least privilege solution. We use a mixture of CloudTrail and CloudWatch for logging, and certificates are entirely issued via automation with no console or human interaction. So that's the main features of the CA. So we sort of realized that if we were having these issues with the cost of the solution, that almost certainly other organizations would be as well. So we decided to make this an open source project. The open source project, all the documentation for that is at serverlessca.com. So that's the only thing you need to remember if you want to access any of this, serverlessca.com, where we have a full set of documentation on the whole solution. There's a link there to the actual GitHub repository, which is open source with a a Linux license. Yeah, if you like it, feel free to give it a star if you wish to do so. That would be appreciated. We've had quite a few different contributors, so yeah, I'd just like to say thank you to all of those, and not just from within our company. We've had others as well, so thank you to everybody who has contributed. And we have we've published the certificate authority as a public Terraform registry module. So yeah, so for those of you, hopefully quite a few of you are familiar with Terraform, which is an infrastructure as code solution to deploy to the cloud and elsewhere, but particularly the cloud in this context. And having a Terraform module for this makes it extremely straightforward and easy for an organization to incorporate the certificate authority to their clouds and to their standard pipelines that they use. I mean, in the simplest sort of end is literally 4 lines. I mean, okay, in practice, that would give you a default name which you'd want to change, but nevertheless, you can deploy this with 4 lines of code. So that means it's easy to get started. And talking of getting started, if we just go back to serverlessca.com, there is a getting started guide that just runs you through step by step how to create a CA and issue a client and a server certificate, so that you become familiar with the project. So let's go back to the presentation. You've seen all of that. As I said, links to everything are at serverlessca.com. So, okay, so we've talked about the certificate authority, but what's it actually used for? Well, you could use it for a number of things. It's particularly well suited to being in AWS, to applications in AWS. And recently, over the last few years, Amazon Web Services have released features for their quite a wide range of their services to support mutual TLS. And these include API Gateway, Elastic Container Service, where certificates can be used to implement TLS encryption in transit between containers and also between load balancers and containers, for example. Similarly, for Kubernetes, we have EKS, Elastic Kubernetes Service, where there's a concept of a service mesh that can also be used, that also can implement TLS between different pods. So we have IoT, Information of Things Core. So the example here might be a car that needs to connect to the car manufacturer's systems to upload telemetry and say that it needs servicing. You only want an authorized vehicle to make that connection, and that again can be secured with certificates. Amazon Workspaces, which is a VDI type solution, application load balancer for web, IAM roles anywhere. And of course, it doesn't just have to be AWS. It could be on-premise, as the certificate authority is X509 standards based, or it could be another cloud like Microsoft Azure or Google Cloud Platform. So plenty of examples of how the certificate authority can be used. So let's just take one of these use cases, and the use case that I'm going to take is API Gateway, where an API Gateway is set up. And then we establish a trust store to say we trust certificates issued by this root CA and issuing CA. We then have a server that's completely outside of the environment, connecting in via REST API and using a client certificate to authenticate. So that's the concept. There's a complete write-up of this on this Medium article. And again, there's links to that on serverlessca.com. And in fact, the documentation of the run-through of what I'm going to show you is also in the how-to guides within the documentation here for API Gateway. So let's just take a little look. So first of all, we're going to go to the AWS account where the certificate authority is installed. So it's best practice to use a different AWS account for the certificate authority itself to provide separation of permissions. So a different account from the one with the applications in. So here we are in this certificate authority account. So I'm going to go to Lambda first, just to show you some of the Lambda functions. So here's one to publish a certificate revocation list. So you can see that it's just fairly simple. Well, not simple, but it's pretty short Python code. Calls a few functions, has a couple of dependencies, but that's what issues the certificate revocation list. If we take a look at KMS, we will be able to see the some of the actual keys that are used. So this is the root certificate authority key, and it is elliptic curve 384. And this is the public key. I can't show the private key because I have no idea what it is. It's been generated by KMS, and it's just never leaves KMS. So I couldn't see it. I'm not able to see it, nor would I want it. Public key looks quite short. That's because it's elliptic curve. Okay, so that's KMS. So let's just have a quick look at step functions. So I mentioned that the Lambda functions are all orchestrated using a step function. So it runs once a day by default, but I can also just start an execution manually. And you'll see here that it's going through the different Lambda functions. So it's checking to see if a root certificate authority exists. It does, so then it moves on to the publish a CRL. And then, if necessary, creates an issuing or intermediate CA, publishes the issuing CA CRL. And after that, then it will just check to see if there's any end user or device certificates that need publishing, need issuing, and then issue those certificates. So that's the certificate authority in operation. So now let's move to the other AWS account which I have, which is the application account. So this is a different AWS account for security separation. So if we go to API Gateway, here we have API Gateway, and we go to custom domain names. You'll see that I've set up a custom domain name, and if I select that, you'll see that I have enabled mutual TLS for mutual certificate authentication. I've configured a trust store that simply has a bundle of the root CA and issuing CA certificates themselves. So that's all set up. And then if we actually look at the API that's linked to that custom domain, we have set up a method request, integration request. There's a simple Lambda function that responds back to the client. So that's what's set up. So let's give it a go. I'm going to connect from my laptop to sort of pretend that that's a server, maybe some collaborating third party. And so I'm going to open up my terminal. And I'm simply going to do, first of all, just do a curl to that that API endpoint. And you'll see here that the connection failed. It's been reset by the peer, and that's absolutely to be expected because when I entered the curl command, I didn't reference any certificates on my laptop. So if I now reference the certificates that I've got on my laptop, here we are. We get a successful response. And if you want to see that in a slightly prettier format, we could just do the same using a API client like Postman, and we get the same response, but it's in color, and we get the response code. So that shows the mutual TLS in operation. So last of all, for this demo, what we'll just have a quick look at here is just look at some of this in the logs. So if we go to CloudWatch, and then we go to log groups, and we look at the gateway access logs, and finally log streams. I might have been a little bit quick here, but this is probably one I did before. Oh, here we are, yeah. So you'll see here that these are the connections that I just demonstrated. We have details of the certificate and the address that I've connected to, etc. So we have logging of all the connections made. Okay, so going back to the presentation, the links you don't really need because you just remember serverlessca.com and it's all there. With that, I'll sort of say thank you. And if there are any questions, please just put them in the chat and I'll have a quick look to see if there are any and then answer some of these. And if you want to reach me, you can do so on the Cloud Security Forum Slack. If you're not a member of that, feel free to contact me or several others who are members. We can invite you. LinkedIn, and I'm also on X. So I'm going to stop sharing my screen at this point. I see there are a couple of questions, so I will answer those. But thank you very much for all your attention. I'm now going to answer the questions. Okay, so I think we've just had a few thanks, and so I will leave it at that. And yeah, just thank you all very much for coming. It's been great, and I look forward to the rest of the conference. Bye.